learning target today, you're going to be able to calculate and analyze central angles today. Given a circle graph or given a situation and table, you're going to be able to calculate what a central angle would be and analyze central angles that are given to you. So this learning target, this first problem, is aligned with analyzing them. If the Johnsons made $3,500 for the month, how much did they spend on the following? So here's their family budget in a circle graph. It looks like they spend 33% of their money on food, 21% on miscellaneous, 15% on clothes, they save 6%, and they put 25% of their income on rent or mortgage. How much did they spend on food? Two ways to do this. You could create a proportion, saying part of their money is to all of their money. Do you see where that came from? X is to 3,500 as part of the percent, 33, is to all of the percent. You could create a proportion. That's the longer way. And then you go 3,500 times 33 divided by 100. And that is, give me a second, that is $1,155. So $1,155 on food. Now that's the 7th grade standards of creating proportional relationships. Quick way to do it that most adults use, you just go percent times amount. So 33% times their total amount of money they make, 3,500. Much quicker. So 33% or 0.33 times 3,500 is 1,155. Your strategy, whichever one you want to make. A lot of kids are into proportions because you've been doing them all year, so you know how to set them up. Let's see how much they spend on clothes. 15% of their total on clothes. So part of their money is to all of their money, as part of the percent is to all of the percent. 3,500 times 15 divided by 100. 525 on clothes. Luckiest, that's good. $525 a month on clothes. Or the quick strategy, you could do 15% times 3,500. Let's see how much they save. 6% of their total income they save. So, part of their money is to all of their money, as part of their percent is to all of the percent. And that is not right. 3,500 times 0.06 is 210. Oops. Quick way, 0.06 times 3,500, which is really 6% times 3,500. So they don't, they don't save a lot, do they? You'll find that happens with a lot of adults and children. They spend a lot on food, they get a lot of pretty clothes, and then 200 they put into savings. It's kind of funny. Why do I have clothes again? What the heck? Cross it out. Just cross that out. So that is learning target number 1, analyzing central angle. This is a central angle that represents 25% of a circle. The saving sector is a central angle that represents 6% of the circle. So what a central angle is, it's part of a circle degree. So a central angle is usually less than 360 degrees, correct? I mean, because a whole circle is 360 degrees. So a central angle is part of it. You can have this little baby central angle, or you can have this huge central angle. Okay? But typically it's the little one. It's the little angle that the sector creates. Okay, why do we care about central angles? Analyzing graphs. Analyzing, oops, I put analyze, that's okay. You can put the ing in there. Analyzing graphs is why we care about them. We care about them because they tell us about a circle. And one of the most important reasons, so put a little heart or something, or a star, why we care about central angles is they let us make a proportion with a circle. That's why we care. You can make a proportion with a circle because it's part of a circle. And if you remember proportions, we always go part is to whole as part is to whole. And a central angle is part of a circle. A whole circle is 360 degrees. Here's the proportions we will use. We will use, let's see, x is to 360. That is part of your angle is to all. As your percent is to 100. So this is saying part of your angle is to all of your angles, as part of the percent is to all of the percent. And then we just do a little skeleton. Just looking up here. Whoops. As part is to whole and percent is to 100. We use that all the time. We just used it up above. Okay, let's apply this. Okay, our last section for today deals with calculating central angles. So we can calculate a central angle today. Notice that everything is given as a percent. So my proportion that I'm going to make is part of my angle is to all of my degrees. So part of the degrees is to all of the degrees as percent is to 100. So looking at this circle graph that's talking about different sports, gymnastics, tennis, track, soccer, swimming, I want to know what is the central angle of swimming. That means right here. What is that central angle? It's hard to see. What is the measure of that without taking out a tool to use it? So I would say part of my angle measure, my central angle, is to all of my degrees as, what percent is it? 27% is to, what's my total percent? 100, bless you. So then I'm going to go 360 times 27 divided by 100. And that is 97.2 degrees. Round it to the nearest whole. So it's 97 degrees. So that's the proportion strategy. Recall from the front page we can do a fast strategy, which is just percent times amount. So if I want to know what is the part of my angle, I could say it's 27% of 360. So you could go 27% times 360, and that will also give you 97 degrees. Faster to do that strategy. Now I want to know how big is the central angle for our tennis sector. Two different ways to do it. Part of my angle is to all of my angles, 360, as part of my percent, 12, is to all of my percent, 100. Then you go 360 times 12 divided by 100 is 43. That's the proportion strategy or the fast strategy where you could see that tennis is 12%, so you could just go 12% times all of the degrees. Okay? So that's analyzing central angles. That's what we did on the front page. We analyzed to determine how much, and then we created the central angles on this page where we created a proportion to find the central angle.